Hello all. So in this lecture, we'll see about exception handling in Python. So there are mainly three types of errors that can occur in Python. So first is compile time error. So this we have already seen. When you write programs, your programmer will make some mistakes. So those mistakes will be detected when you compile this. So those errors are known as compile time errors. Then there are logical errors. So this is actually made by the programmers themselves. So there might be some the logic what you have done might be wrong. So in that case, instead of addition, it will be subtraction, or instead of multiplication, it will be division that will be happening inside the code. So due to that, errors might occur in the result. So when you compile and all, this logical error will not be detected. After compilation, when you run that program, you will find that you will be getting the actual result. Then we call that as logical error. Then the third type of error is runtime error. So this type of error occurs due to some unintended circumstances. Maybe we may not see that. We may not, the programmer might not see those errors. So they might have written the program correctly. There won't be any logical error, but in certain cases, some kind of error might occur. For example, if some input is taken from the user and you are asked to divide two numbers, you ask the user to give two numbers, 5 and 6. Then you will be dividing it 5 by 6 and you will be giving the result. So instead of that, if the user gives 5 and 0 and you try to divide it 5 by 0, it is undivisible. So it is zero division error. So such kind of errors can occur even when the programmer does not commit such kind of errors. There are errors that can occur when the user gives some wrong input values or some other problems that might occur with the user side. So those are known as runtime errors. So we will be dealing with this runtime error. So we call it as exceptions in Python. So these runtime errors are known as exceptions in Python. So we have to deal with such kind of errors. So we will give some examples. I'll show some examples, then you will understand. So, okay. So let me write a program, a simple program. I am asking the user to enter two numbers. So we have already seen all these statements. Input and a number. Okay. Then we are asking the same user to enter another number, b equal to enter a number. Now we are trying to divide a by b. So what we are going to do is we are dividing a by b. And after that we are printing thank you. So we are printing thank you. Anything. Okay. So this is a program. So we are asking the user to enter two values which will be stored in a and b. Then we are printing this a and b. We are printing this a by b and we are printing this that. Now, so let it be some name I'm giving. Okay. Now if I run this program, you will be prompted to enter some value and I'm entering some value. If I enter 5 by 3, you will get the result as 1.66667. Now, and you will get that printed, that thank you message also. Now a problem can occur. So I will run the same program again. Now if I am entering 5 and then I am entering 0, now there is an error. So it is known as zero division error. So division by 0 is not possible. So there is some problem with the program. So we call this as zero division error. So we have to deal with such kind of exceptions. This is actually the problem with the user. The user tried to enter some other value which is not permissible. So we have to deal such kind of errors. We call these errors as exception. Now what we do is, so here what we have to do is, so this is a statement that causes that error. Here, if somebody gives B as 0, then that problem can occur. So what Python does is, we call this as try block. So what we do is, we put that statement inside this try block, inside that try block. Now, what this means is, you are asking the compiler to try if it is possible to execute the statement, whether it is possible to execute this statement, whether some error occurs. So if some error occurs, so what we have to do is, if some error occurs, then the possible error, so what we have to do is, if that error occurs, we have to do something. So we are simply printing here, division by 0 is, you can print anything. So here what we are trying to do is, we are including that statement print A by B inside a try block. Okay, so this is a try block. So we are asking the compiler to try to execute this statement. So if there is no error, then you can execute that statement and you can simply go outside this thing. Okay. So you try to execute the statement. If there is no error, the statement will be executed, and after that, this statement will be executed. So you can put any number of statements inside this try. Then if there is some error, with this statement, if you try to execute and if there is some error during that runtime, so it will go to this part, except part, and exception is a class. So what you have to do is, you have to print. You can print anything. You are printing that division by 0 is not visible. So this is a meaningful reply to the user. So now the user will understand that I have given a wrong input. So if you try to execute this thing, you can find that you are trying to enter 5, and if you are trying to enter 0, then you will get a marker. You will get a reply as division by 0 is not possible. Thank you. Now, if you try to execute this same program with a value like 5 by 2, then you will get the correct output also. So this is the try. So this is how you will handle exception in Python. Okay. And if you want to print that error also, it is possible to print that error. So you can give some object. So E is the object value. You can name anything. I am giving it as C, exception as C. And if you want to print the system error message, what is the actual error message also, it is possible. You can print the T and C, what that error is. So if you run this program, and if you give some value like 5 by 0, so division by 0 is not possible, and the error name is division by 0. So that exception name is division by 0. So in this way, you can tackle such kind of errors. Now, in some cases, you will learn it when you learn this files and all. So if you open a file, you have to close that file before exiting that system. If you open a file, then after completion of the execution, you have to close that file. Otherwise, that file will remain open and it will create problems. You will learn that files and all in later sessions. So if there is something like that, if you want, I will take a simple example that if you have, I'm just printing a statement here. There is some resource open. It may be any file or something. So after in this resource open is printed here. Okay. Then you are printing this thing. And after that, you have to close that also. So you have to close that option also. So I'm simply printing. So actually, if it is file, you will be simply opening and closing the files. You will learn how to open and close file and all later. Here I am simply mentioning as resource close. Okay. Okay. So in this way, I'm trying to print this thing. Now I'll run the same program again. Now I'm entering 5 and I'm entering another number 0. Now here resource is open, but the problem is here division by 0 is not possible and division by 0, but the resource is not closed yet. That's the problem here. Now if I give the right input, if I'm not giving any 0 as input, then here the resource is open, the value division happens, and since inside resource closing is happening inside the try block, then you can include this. So that will be executed. So another way to include this, you have to include that inside this exception block also. Then even if we give 5 and 0, everything will be happening. So resource close, resource is open here, division by 0 is not visible, and resource is closing, where we are closing the resource also. So in this way you can do it. But this is not always good, because there are many exceptions that to be caught, because we are catching only a single exception here. There are various kinds of exceptions that can occur here. So if you want to catch different exceptions, you cannot include all the statement everywhere. So it is not good to include the statement everywhere. Instead, what Python does is, there is another block called finally. There is another block called finally. So you can remove the statement from here and here. Okay. Now there is another statement another block known as finally. So this is try, except, and finally. So what happens is it will try to execute these statements. If there is some error, then the except block will be executed. Or if there is no error, then also this block will be executed. After execution of try block or the except block, what happens is it will execute the finally block and it will go out. So in this way you can do this thing. So if you want, I'll run this program. So now if I am giving a 5 and 2, here resource is open, then 2.5 is well, then the finally block is executed. Resource closed will be executed and thank you will be executed. Or if you are giving a value as 5 and 0, then also that resource open and resource closed will also be executed. That is, the finally block will be executed. Whatever happens, whether it is executing in the try, if there is error, then it will execute this except block, and after that the finally block will also be executed. So in this way we can do this thing. Okay. Now we will do some other example. Now if I am trying to do the same program, we have got only this division by 0 exception. Now let me do the same thing. And giving value different. So you are asked to enter a number, but instead of a number, I am trying to enter some character. So when you try to enter a character here, the value error will occur. Here there is a value error that is occurring. We call it as invalid literal error. So since we are expecting int and we are simply giving as a, so it is an invalid literal error. So this can happen. So if you want to catch such kind of errors, we have already caught division by 0 error. If you want to catch such kind of errors also, what you have to do is we have to include these two statements inside this block. Okay, now you can remove these two statements. Now I have included it in this statement. Now if you try to execute this statement, and the number happens. Now what happens is if I give this a, now what happens is there is an error message, but it is division by 0 is not possible and it is invalid return. But actually it is not the error. I have given a And division by 0 is not the message that you want, it is actually the invalid literal that you want. So if you want to catch different errors, there are different types of exceptions in Python. So if you want to catch different types of exceptions, you can do the same thing. What you have to do is, so in order to catch this zero division error, so what you have to do is, you know the class name. So zero division error, that is a class name, as E. So if zero division error occurs, it will go to this block. Now, I'll use the same statement here. If another type of error, that is, we have already seen, it is value error. So there is possibility of value error also. So value error. So if value error occurs, we have to give some other message here, invalid input. Okay. So in this way, you can execute this thing. So it will catch, this is catching of multiple exceptions. So if division by 0 error occurs in these statements, then this block will be executed, and after that finally will be executed, and then the following statement will be executed. If value error occurs, that is, if you are not giving, if you are giving some character instead of integer, then also this the error will be caught, and this block will be executed. And then after that, this finally statement will be executed, then thank you will be executed. So we'll run this program and see. So if I am entering 4 and I am entering the second number as Q, so it is an invalid literal. So here invalid literal error, invalid input, that message will be printed here. Okay. And if you are trying to execute the same program with 5 and 0, you will get division by 0. So in this way, you can handle multiple exceptions also. You can handle multiple exceptions. So if you know which all exceptions can occur, you can include different blocks for that. So everything should be included in the try block, and whatever error occurs, so it will be calling that particular block. So in this way, you can handle multiple exceptions. So there are different errors in exceptions in Python. So if you see, these are some of the base classes. I will show the base classes. This just to understand which all errors are there. So you may not by heart all these things. Right? So we have this base exception. This is the base of all, parent of all classes. Then we have four different classes. So in exception, we have all the exceptions. So these are other exceptions errors that can occur. So we usually include all these exceptions. So there are different exceptions inside this. So under arithmetic error, we have the following: floating point error, overflow, and zero division error. Then if you have, there are different types of errors: index error, key error, like this. There are different. Under OS error, we have a set of errors like this. Then also file exist error, file not found error, like that. There are different errors. Then syntax error, indentation error, tab error. If you miss the tab and all, then we can provide warning also. So that we can provide different kinds of exceptions. So we have seen this value error like that. We have type error, system error like this. There are different kinds of errors. So you can include any of these classes so that you won't to go through all the errors. You can deal with all those errors that can happen in your code. So these are some of the exceptions. Exception, it's a base class of all exceptions. Under that exception, it contains the stop equation, system exit, standard error, arithmetic error, overflow error is there, then floating point error, zero division error, assertion error, attribute error, end of file error, the import error. So there are different errors inside this. Keyboard interrupt. These are some of the errors: lookup error, index error, key error, name error, unbound local error. So whatever errors that can occur during that runtime, you can include in the try and except blocks. So in this way, you can handle all these type of errors. These are some of the errors that I have listed here. So there are any of these errors can occur during runtime. Then system exit type error, value error. We have already seen this value error, then front time error, not implemented error like this. Then we can have user-defined exceptions also. So it is possible to include user-defined exceptions. Instead of including the exception from the exception class, we can have our own user-defined exceptions. So if we will declare a class like custom error, and it should be imported from this, or it should be the subclass of this exception class, and we are not including anything statement, so we are simply mentioning as pass. What you have to do is you have to use this raise. So if some error raises, you have to call this class. So inside this class, all those errors will be defined. So we'll see an example, then you will understand what this is. I'll show another example. So this is another example. This is from sys module. I have imported a sys module here. Now we have a random list here, A, 0, and 2. Now for entry, this is actually an example for the try except block. So for entry in this random list, so it will be given as one by one. So it will be taken one by one. So in the first iteration, it will be A. Then second iteration, it will be 0. Then in the third, it will be 2. Now we are trying to print the entries. So entry will be printed. So in the first iteration, this for loop, first iteration, A will be printed here. Then what we are doing is 1 by int of A. So this will cause an error. So what it will do is, since it's inside the try block, what it does is it will go to the except block and it will print, oops. So there is a function, a method exe dot underscore info. It is inside this sys. So we will get the actual error that has occurred. So we can print the actual error using this statement, sys.exe underscore info. And then it will go on like this. So if you see this, the first type of error occurs when A is given as input, because 1 by A it is not possible. And the second, when 0 is given in the second iteration, 1 by 0 happens. So the 0 division error will be printed. Then in the third case, 1 by 2, it is possible. So there won't be any error. So if you run this program, you can see this. So the first, in the case, entry is A, and oops, class value error will be printed. Then next entry is 0. Here class 0 division error has occurred. Then after that entry is 2. There is no problem. The reciprocal of 2 is 0.5 will be printed. Okay. So this is an example for try and except. Now I'll show another user-defined custom errors for custom exceptions. I'll show another program. So this is actually for custom exceptions. So user-defined exceptions. So what you are doing is you are including a class called error, which is inherited from this exception class. So this is the base class for all exceptions. And we are not declaring anything, defining anything. We are simply mentioning as pass. So whichever class imports this error class should have the definition. So here we have a class value too small error, and it is inherited from this error class. And another class is there, value too large error is there. That is also imported from error class. So here this is raised when the input is too small, and here also we are simply mentioning as pass, and here also we are mentioning as pass. So what we are doing is we are giving a number inside the program. It is 10. So you have to guess that 10. So if you are guessing 25, it will say the value is very large. If you are guessing it's 1, you have guessed very low. So due to iteratively guess the number and try to get it to 10. So that is a program. So here what we do is while true, so it will continuously do this. So this is inside the try block. So inside this try block, enter a number. So user will be asked to enter a number. If that number is less than that number, less than this 10, then we are raising this value to smaller. We will raise this value to smaller. So what it does is, it will, since we have used this raise statement, it will execute this except block. So this is actually user-defined error. This value to small error is not there in the Python. So we are defining a new exception. This is known as value to small error exception. So we are defining this thing. So what happens is, what we have to do is, if the number we have entered is very less than the number, that is, it is less than 10, what you have to do is, you have to raise this thing. That means you have to execute this value to small error box. Or else if the number you have entered is greater than 10, then you have to raise this value to large error. That is, you have to raise this exception block. So inside this, we are simply printing the value is too small, try again. So again, it will go on repeating like this until you guess the number correctly, until you get the, guess the number correctly. So if you run this program, so this is how it happens. So we define a class error here. So it is a child class of exception class. So exception class. Then we are not defining anything here. We are simply mentioning class. Then again, we are not defining anything inside this value to smaller, which is inherited from this error. And also we have value to large error. Another class we are defining, which have no other statements here. Then if that error occurs inside this try block, so this is the try block. So if that number you have entered is less than that number, then you will be raising this value to smaller. So this except block will be executed. So this except block will be executed. Then if the number you have entered is greater than number, then this except block will be executed. Okay. So we will run this program. So you have to guess the number 10 correctly. So you are asked to enter some number. So I am giving 1,000. So the value is too large. So that except second block will be executed. Then again I am entering as 500. Then what happens? Again the second block will be executed. Now I am simply entering 1. So the first except block will be executed. This value is too small. So I try to enter 5. Again it says it's too small. Then I enter 25. So it is too large. 265. So it is too large. Similarly, it will go on like this. The value is too large, so I will enter 11. And finally, when I enter 10, it will say that congratulations, you have guessed it correctly. So in this way, you can execute this program. So this is included in the try block, and these are all custom errors. These two except errors are custom errors. So we have defined our own custom error class. This is our own error class, and we have defined two types of errors. So these are all user-defined exceptions. And we use the raise statement. If that type of error occurs, we have to raise this error. So it has to execute this except block. Otherwise, if you want to raise this thing, so this exception block will be executed. So this is another example. Okay. So these are the references. Thank you.